Hello everyone, welcome to Ajurai's channel. This is 20 minutes challenge day 8. We are going to continue with Sabbath Quest Kips Learning grade 7 with Tinkercad programming. We have started with 5th chapter circuit drawing using Tinkercad. In the previous video day 7, we have seen designing of series circuit, parallel circuit in the Tinkercad software tool. And in today's session, we are going to see the lab session. At page number 68, we have lab session where we are going to make a circuit using the list of components given over here. There is LEDs, resistor, coin cell of 3 volts battery, and a multimeter. So we are going to design this in today's session and we'll complete this chapter 5 today. And in the next day 9, we are going to see some quiz related to chapter 5 and also we'll be seeing quiz on Python programming. I hope you can please go through the Google form link I'll be sharing in the comment box so that you can go through these questions to test your knowledge. Okay, let's start with 20 minutes of challenge and we will go with this lab session. So we are going to design a simple circuit, parallel circuit with multimeter design on that. So we'll go with this Tinkercad tool over here. Click on the Google, type Tinkercad. Already my account is linked to this, so I can directly open it from here. Those who are new, please click on this create and click on circuits so that you can open the window where we can design the circuits. Now here in this video we have this is the name by default given. You can rename it as per your requirement. So you can just double click on this. This is our lab session, or you can name it anything that you want. Here is a toolbar where we will be making use of few of these during the circuit designing. The most important thing here is here we have these components, the components that you want to select and keep it in your circuit diagram, or else you can just search it over here. Then we will be making use of this start simulation to run the program, to run the execution of our circuit. If it is Arduino programming, we will make use of this code. If not, we will not use this one. There is an option of sending to or sharing with the other people or other apps. So you can click on this send to option. So let's start now. We will make use of coil cell. Just click on the component whichever you want. The cursor automatically will hold that. So place it over there. Let's turn it around to make a parallel circuit. I need LED. Click on the LED. Place it on the top. Now we have this anode, anode connection and cathode connection. So we will place this anode and cathode through resistor. We are going to connect these LEDs. Please, those who already knew about Tinkercad can start doing along with me. Place the resistor. You can rotate it a bit so that the resistors can be connected over here. I need one more resistor, three resistors for three LEDs to connect. So this is the second resistor and this is the third resistor. Right. So if you go back to your textbook, you will see that we have these LEDs connected with the resistors. 1, 2, 3, 4. They have taken 4 LEDs with 4 resistors. Okay, we'll go with 4. So we'll take one more here, rotate it, LED, right? Now if you see here, we are making use of multimeter. You can just type here multimeter. This is multimeter. Place it on this. Now we are going to make the connections from resistor to the LEDs and from LED to the coin battery. It needs little practice for you to connect these wires. So we are done with these connections. So if you see, all these wires are connected. Now going with the resistor, we have these resistors connected to one end of the cathode. Now let's connect it here. And if you see, the positive terminal is connected to this and negative terminal is connected here. So the circuit as per the given we have designed. Now the resistance value you can change it to kilo ohms or ohms. It can be any resistance value that you keep. Related to the resistance value, you will see the effect on LEDs. Now the circuit design is done. We will start the simulation. So you will see that these LEDs are glowing. These 3 LEDs are glowing. And because the fourth LED is not connected, is showing 1.12 milliamperes of current. Let's keep this as ohms. Okay, we'll keep this as ampere. And the resistance, we'll keep it as kilo ohms. Now this is okay. Now you see we have ammeter, voltmeter and the resistance AVR. This multimeter is used to measure current represented by amperes. I mean, this is the unit of current actually. Volts, V, resistance R. So when I am using this as an ammeter to current measure the current, it is giving you as 1.12 milliamperes. Milli is 10 power minus 3. Amperes is the amount of current which is passing through this resistor and LED. So here when we have kept this resistor of 1 kilo ohm, the amount of current that is passing is 1.12 milliampere, sufficient for glowing this LED. When I make this as voltmeter, here the current divides. the voltage that you are applying, 3 volts, will be parallel among these things. So that is the reason your LED is not flowing over here. When you keep it as amperes, your current will be same throughout the components in series. Okay, as of now, you may not understand this properly, but just remember, as you are measuring the current, you are keeping this as milliamperes. So always remember it should be in amperes, and you will see all the LEDs are glowing. Now, with respect to this 3 volts of coin battery, I have connected uh, resistors of 1 kilo ohm. If I increase the resistance, let's say decrease the resistance value, you will automatically see that LED is glowing little bit brighter with a error message saying you that 20 milliamperes is the current it requires, but 57 milliamperes of current you are providing to the LED, which may burn the LED. So make sure your resistance value that you are connecting should be like limiting the current, that is amount of required current only is being provided to that. Okay, so that's it. This is our lab session circuit that we have designed. And apart from this, if you are doing any other programming, such as if say you are going to use Arduino board. So I want to show you, if you are working on Arduino boards, just type Arduino. Here in this component list, you will see many example programs which is already done, right? So, let's say if I want to blink LED, so you will just click on this example, blink, place it over here like the component as we have done before. Just place it on this. You will see that the component with the complete example is placed over here. Now, if you see, this is an Arduino board. This will be like your computer system which is programming. Like you will program it so that you can do some work onto that. Now here, if you see the comparison between this circuit that you have done, apart from the circuit that we have in the Arduino board, the difference here is, here in the coin battery, the power supply is continuously given to this LEDs. You don't have any control apart from this resistance. You don't have any control to make this LED glow, blink, stop, start. You cannot do, because power is continuously being provided. Whereas the Arduino board, if you see, here we are programming this. Programming in the sense, now if you click on this code, here we have got options like block coding. If you have done Scratch program, you will understand this is like block coding. If you don't know about block coding, you can go with text. Click on continue. Now this is Arduino program. We'll have two functions, void setup and void loop. Now this program will be there by like default, that like ready-made. You have to just use it and play it. That's it. You don't have to write program for yourself. Program is already there. So just click on this code and start simulation. Now when you start simulation, both of this Arduino and this coin battery will be running. Here if you see in the Arduino board, this LED is blinking on and off continuously until and unless you are not stopping this one. Now this on and off is because I have written that in the program. So if you see in the code, you will see high and low. High means on, low means off. So in the program, I have written LED to blink, to turn on and off for some time. That is for some delay, thousand of milliseconds of delay, it will be blinking. Here in this case, if you see coin battery, as soon as power supply is provided, it is continuously on. You don't have any control to make it off, to blink, anything. You cannot do it. But when you go with the programming part, you can control it in any way. So these are all examples for different components that you can try. You need not worry at all because all the programs are there. Even it's all ready made. Like examples, programming, everything is given. There is a buzzer sound, tone multiplier, tone pitch follower, ultrasonic range finder, LCD display, right? So all these examples are already there. You have to just pick and place it and use it. And once you understand this, you can go for modifying as per your project. So let's say if you're doing any project in your school, then you can change it as per your school project. Okay, so this is like just a brief introduction of Arduino. In the next session, if you are interested like learning more about Arduino on the Tinkercad tool, please let me know in the comment box. I'll be just explaining you one by one all the examples or any particular projects that you want to work on. All right. That's it for today's session. I'll be stopping over here. We are done with this Tinkercad. Sorry, chapter 5. If you have any doubts, please let me know in the comment box. And in tomorrow's session, we'll be going with a small quiz related to this Tinkercad and Python programming. Okay, that's it for today's session. Bye bye.